Hi guys, it's me Sitanga, back again with Learn with Sitanga, and today in this video we're going to be looking at a probability question from the Edexcel IGCSE Mathematics Specimen Paper 1H. Alright, let's look at this. Question number 22. There are 7 red counters in a bag. So in a bag I have 7 red counters. I use balls to represent the counters. The rest of them are blue. So I have some blue ones as well. Okay. There are more blue counters than the red. That means the blue counters has to be greater than 7. So if blue counters, so I'll take blue counters, the number of blue counters, I'll take it as x. Alright. So if the number of blue counters is x, what would be the number of total counters? Total would be, I have 7 red. Alright, I have 7 red, I have x blue. So my total would be, total is red plus blue, which is red I have 7, blue I have x. This would be 7 plus x, right? This is my total. Total is 7 plus x and blue is x, right? Since we've established that there are more blue counters, so x has to be greater than 7, right? So we'll need this at the end. 2 counters are to be taken at random from the bag. So a person takes one counter and another counter. So they don't say the first counter that they take is not replaced back, right? They don't say that. They don't say whether they put it back. That means the one he takes, it's not being put back. Alright. So that means when the second time when he takes another one, what happens to the total number of counters? It reduces by 1 because he took one in the first chance. Okay, 2 counters are to be taken at random from the bag. The probability that there will be 1 counter of each color. So when they take, the probability that there will be 1 counter of each color. So that means, can I have the first, alright, can I take first a red counter and then again a red counter? No, I can't do that. Can I take a blue counter and then second time also a blue counter? No, I can't do that because they're saying that there will be 1 count of each color. So can I take a blue counter first and then a red counter? Yes, I can do that. Can I take a red counter first and then a blue one? That also I can. So it's either this or this, right? O, and we learned O in probability is plus. Okay, so the probability that there will be 1 count of each color. Okay, so let me write this down. 1 counter of each color. Color is going to be the probability of blue. First part is blue and red, right? First time he takes a blue and then second time he takes a red. So blue and red. So blue and red, or right, it can be either first blue then red or first red then blue, right? So this is what I wrote here, or this red and blue. So O, probability of red and blue. Alright, hope you understood this. Now I just have to find the probabilities. Alright, taking into account this one, what would this be? Let me take another colored pen. I'd have probability of blue and red. So we know and is multiplying probability and O is plus. Okay, let's get that sorted. Let's write that in here. So and means multiply, O means plus. Okay, and means multiply, O means plus. Probability of taking a blue first and an R. What's the probability of taking a blue? Now probability of taking a blue is the number of blue counters over the total. So blue I have x and total I have 7 plus x. So probability of taking a blue is the number of blue counters over the total, which is 7 plus x. Okay, now when this person takes a blue first, what happens to the remaining total number? Total number reduces, right? So total 1 in here. So now AND means I put multiply. Okay, so this AND here means I put a multiply. Now when the second time we take a red, what happens to the total number? It reduces by 1. So 7 plus x minus 1. And what happens to the number of red counters? So number of red counters is 7. Did the person initially take a red one? No, which means there is no effect on the red. So I'd have 7 as the number of red ones. Okay, that's my first part here. Okay, and then I have O in probability is plus, so I put a plus. And then I have probability of red first. Initially we did blue first, then R. Now it is red first. Now what's the probability of taking a red? The number of red over the total. So we know the total is 7 plus x. Okay, so this is a new trial. So we have the original number of things, 7 plus x. Is probability of red is number of red over total. So how many red we have? We agreed that we had 7 red, right? So we have 7 red, which they gave in the question. And here means multiply, so I put a multiply. And then now probability of blue. Again, since in the first time we took one counter, how many do I have remaining? I have 1 less than the original, so 7 plus x minus 1. Now the probability of blue. Did he take a blue first? No. So does that affect the number of blue ones? No, blue ones remains as it is. How many blue ones do we have? X. So I would have x as my numerator. Okay, and what did they say the probability of taking one count of each color? They said the probability that there will be one counter of each color is 7 over 15. So this answer is actually equal to 7 over 15. Now I have to solve this. 7 times x is 7x over, so this one is 7 plus x, this is 7 minus 1 is 6, so I have 6 plus x. So in the denominator I have 7 plus x and 6 plus x, plus in here also I had the same, right? 7 times x 7x, 7 plus x, and here 7 minus 1 gives you 6, so 6 plus x. So it's the same thing basically. We have the same thing twice, but you can't write it only once, right? Because both of them are possibilities, either blue first then R, or red first and then blue. Okay, I have here 7 plus x, 7 plus x and 6 plus x. This is equal to 7 over 15. Since I have the common denominator, I can add the numerators, right? So then 7x plus 7x becomes 14x. It's not 14x squared, it's just 14x. Okay, 14x over, we would have the same denominator, 7 plus x, 6 plus x equals 7 over 15, right? Now what I would be doing is cross multiply. So 14x multiplied by 15 and 7 multiplied by this. So I have 14x multiplied by 15 and 7 multiplied by this thing, which is 7 plus x and 6 plus x, right? So I just created some space at the top for us to continue this. 14 times 15 is 210x. So I have 210x, 210x equals, on the right we have 7, and this I'll expand this, 7 times 6. So if I just expand it in here, I have 7 times 7 times 6 is 7 times 6 is 42, 42, and then 7 times x, 7x. I'll just quickly expand this, guys. 7x plus 6x plus x squared, and then if you take this one, I have 42. 7x plus 6x is 13x, 13x plus x squared. That was just to expand this part here. So I have 7 42 plus 13x, 7 42 plus 13x plus x squared, right? Now I would be expanding this. So 210x stays as it is. 7 times 42 is 294, 294 plus 7 times 13 is 91, 91x plus 7x squared. Now I'd be bringing the 210 to the other side as well. I have 7x squared plus 91x minus 210x when it comes to this side, and then I have plus 294, and this is equal to 0. So here 7x squared, 91 minus 210 is minus 119, minus 119x plus 294 equals 0. Now I would be solving this quadratic using our calculator. A is 7, B is minus 19, minus 119, sorry, and C is 294. This gives me answer 14 and 3. That means my factors are, if the answers are 14 and 3, 14 and 3, I have x minus 14 and I have x minus 3 equals 0. So my answers are x equals 14 or x equals 3. Now we knew that there are more blue counters than red. Red alone we have 7. So what would be my answer? Can I take 3? No, 3 is less than 7. So I have to reject this answer, and my only answer is x equals 14. So guys, that means I have 14. Now what I found here, x we took as, remember we took x as a number of blue counters. So I have 14 blue counters, and the total they are asking in the question, work out the total number of counters in the bag. So total we knew it was 7 plus x. So total it was 7 plus x. So my answer is 7 plus 14. What is this? This is 21. So my final answer to this question is 21 counters. Alright guys, thank you for watching. Please do let me know in the comment section what kind of videos you need next. Thank you.